This is section 1514, sorry. Identifying properties. We're going to start with additive property. What that means is when you add 0, it actually doesn't do anything. So a plus 0 is equal to a. An example would be 4 plus 0 is still 0, so it looks like we didn't do anything. The additive inverse is when you add opposite numbers to each other. So a plus a negative a would be 0, or 3 plus a negative 3 is also equal to 0. The next one is the multiplicative inverse, identity. And what that means is that when you multiply by 1, it doesn't do anything. So a times 1 is a. So what does that mean? That means like 4 times 1 is still equal to 4. It looks like we didn't do anything. For the next one is a multiplication property of 0. When you multiply by 0, it always equals 0. So we could say that 7 times 0 is equal to 0. And no matter what you multiply by, for example, x times 0, it's still going to be 0. The multiplicative inverse property means that if you have a fraction and you flip it, it's going to equal to 1. So they have a times b is equal to b times a. And what happens is that this reduces and it becomes 1. Let me give you 2 examples. 3/4 times 4/3. They simplify to be 1, and these simplify to be 1. That's why your answer is 1. But the example that I wanted to give you is 1/4. Because what it looks like you're just going to multiply by 4, because 4 is a numerator. So what's its denominator? It's 1. We don't need to write it. That's why it doesn't look like it's its inverse, but that's kind of important. And this equals to 1. So I would start this one. We'll need it for later. The multiplicative inverse property. The reflexive property means that you have the same thing on these equations. So for example, a, and let me write an a that looks like an a is equal to a. And what it looks like is this 3 is equal to 3. If you get a solution like this on your test, you need to say that this is infinite. Solutions. It's always true. Or you could also get something like this, x is equal to x, which means that this is always true and you're going to get infinite solutions. On the next one, the symmetric property, what it does is change the order of things. So I have a is equal to b, and I can write that b is equal to a. What it looks like in our math class, it looks like x is equal to 4, and we can change it to 4 is equal to x. On the last one is the transitive property. And this part right here is the one that helps you identify the transitive property. And what it results in is that a is equal to c. What that looks like in our geometry class is that if we know that x is equal to y and y is equal to 7, then we can just eliminate that part and have x is equal to 7. And that's the transitive property. Substitution property, so if we know that x is equal to 3, we can use that. For example, if 3x plus 7, that means that we could substitute it in and have 3 times 3. Because of that one right there, plug it in, plus 7. The commutative property, what it says is that it doesn't matter if you change the order, it's still going to give you the same values. It works for addition, so I could have b plus a, and multiplication, and I can write b times a. So what it looks like in our class is that if we have 4 plus 3, that's equal to 7. We could write a 3 plus 4, and that's still equal to 7. Or 4 times 3, which equals 12, and that's going to be the same thing as 3 times 4, which also equals 12. And that's the commutative property. The associative property is that you can change the parentheses around and still get the same value. So I have a plus b plus c, and you're supposed to add these first. But you could also say A plus B plus C, and add these two first, and you get the same value. So for example, 1 plus 2 plus 3, if I add these two first, that's 3, plus 3 is equal to 6. Or I could write 1 plus 2 plus 3 and do these two first, that's 5, and add one more, it would still give me 6, the associative property.